Hello everyone, my name is K. Srinitya. Today I am telling the topic about set theory. What is a set? A set is a well-defined collection of distinct objects is known as elements. Think of sets as fundamental building blocks in mathematics, allowing us to categorize and organize information in everyday groupings. For example, the set of fruits in flower brackets apple, banana, orange. Each item is a distinct object. Here the elements are enclosed by the flower brackets. It is represented the set identity. Here the numerical collections or the set of whole numbers 1, 2, 3 are enclosed by flower brackets. This defines as a specific limited collection. Infinite possibilities. Even numbers can form a set. Here the flower bracket open 2, 4, 6, 8, 10 and close the flower bracket. Sets can contain both finite and infinite number of elements. Here the different types of sets. Sets come in various forms, each with unique characteristics that define its contents and relationships with other sets. Understanding these distinctions is crucial for working with set theory. Here the first type of set is empty set. It is also called a null set or zero set. This is a set containing no elements at all. For instance, the set of all cars that can fly without mechanical assistance. This set is useful for other sets. Here, the second type of set is the finite set. It's set containing a countable elements or limited number of elements, such as here the one example is the months January, February, March. These months are in a quarter representing. Here the third type of set is infinite set. Contains an unlimited number of elements like the set of all natural numbers. Here natural numbers are starting from 1 and ending from infinite number. We cannot define these numbers which extends indefinitely. Here another type of set is subset. A set where all its elements are also present in another large set. For example, red blue is a set of red blue green. Here the red blue green is enclosed by flower bracket. Here the set is the big and subset of this set is red blue. Here the universal set. Universal set encompasses all possible elements relevant to a specific context. Universal set is a combination of complement and normal form of the subsets. If discussing colors, you might be the set of all primary and secondary colors. Here the five types of sets and the operations overview. Here the operations are useful for the complex problems to simplify easily. Here just like in numbers have operations like addition, multiplication, here sets also have an operations like union, intersection, difference, complement. Sets are operations that describe how they relate to each other and how new sets can be formed from existing ones. These operations are fundamental to solving problems in set theory. Here the first operation of the set is union. Union is represented as A union B. Here union is also like U. A union of B. It is enclosed by brackets. Here the definition of union is combines all elements from two or more sets. Here one set containing some elements and another set containing other some elements. Here the A union B can be written as some or combination of the elements in one set. Here the duplicates are not allowed. This is the main important point in this union. And the other set is intersection. Here the intersection is represented as A intersection B are shown below. It is identify elements common to all sets. Here for example, a set containing 2, 4, 6 and another set containing 2, 4, 5. Here the common element is 2. It is the intersection. It defines a common element from the both sets. And the other operation of the sets is difference. Here difference is represented as A minus B. Here A is a one set and B is a another set. The difference of these two sets is difference and subtracting the B set from A and write the remaining elements from the A set. Here find elements present in one set but not another. That's like B. Complement. Here the one of the observations. Here complement is present in universal set. Here the complement of A is obtained by subtracting the normal form of A from the universal set. Represents elements not in a given set related to a universal set. Here the normal operations, and one of the important operations in the set theory is De Morgan's, and we study next. And the brief explanation of union. Here union of A union B is the union of two sets A and B, denoted as A union B, is a set containing all elements that are in A or in B or in both. It's like combining all the items from two separate lists into one large list without duplicate. Here the one of the example, A union B is equal to, it is enclosed by flower brackets 1, 2, 3, 4, 5, 6. Here notice you how 3 and 4 are only listed once, even though they appear in both sets. Definition: all elements in A or B are both. For example, here A is containing 1, 2, 3, 4, B containing 3, 4, 5, 6 elements. So A union B is equal to 1, 2, 3, 4, 5, 6. We discussed previous is duplicates are not allowed in A union B. So here 3 and 4 are not repeated 2 times, even though they appear in both sets. Here the other type is intersection operation. Intersection operation means A intersection B. The intersection of two sets A and B denoted as A intersection B is the set of all elements that are common in both A and B. Identify what elements the sets share. A intersection B is equal to 4, 6. Only the elements present in both sets are included in the intersection. Here the definition is elements common to both A and B. For example, A containing 2, 4, 6, 8 and B containing 4, 6, 10. This is the explanation of intersection. And another operations is difference, A minus B and complement. These two operations helps us define elements that are not included under specific condition, providing precision in set definitions. Difference A minus B. Here the definition is element in A but not in B. For example, imagine A is your full music library and B is music by one specific artist. A minus B would be all your music except in artist songs. Here A containing 4, 8, 12 and B containing 4, 5, 16. Here the subtraction of A and B is equal to 8, 12. Here 8, 12 is containing in the set A. So another operation is complement. Here complement definition is elements in the universal set U that are not in A. For example, if U is all numbers from 1 to 5 and A is prime numbers 2, 3, 5, then A complement would be 1, 4. Here universal set 1, 2, 3, 4, 5 is enclosed by flower brackets. Here A containing 1, 2. From these two we obtain the complement of A, that is subtracting the normal form of A from the universal set, then we obtain complement of A. Here the complement of A values are 3, 4, 5 are enclosed by flower brackets. Here the laws of sets. Set theory operates under several fundamental laws that govern how sets interact, similar to algebraic laws of numbers. These laws are critical for simplifying expressions and proving identities in advanced mathematics. Here important laws are: first law is commutative law. The order of operation does not change, affect the result. Here A union B is equal to B union A is the same answer is obtained if you interchanges them. Both numbers are variable. Here A intersection B is equal to B intersection A. This is the commutative law, and another law is associative law. The grouping of sets does not change the outcome for multiple operation. A union of B union C is equal to A union B of union C. Here A intersection of B intersection C is equal to A intersection B of intersection C. Here underlies distributive laws. Operations can be distributed over others, much like multiplication or addition. A intersection of B union C is equal to A intersection B union A intersection C. Here intersection is distributed over A intersection B union A intersection C. Here another one is A union of B intersection C is equal to A union B intersection A union C. Here the one of the important law is De Morgan's law. De Morgan's law provides a way to relate the union and intersection of sets, though their complements. They are incredibly useful for simplifying complex expressions involving set operations and negations. Here it is represented as A union B whole complement is equal to A complement intersection B complement. Here union is interchanged by the intersection and intersection is converted as union. Here A is changed as A complement and B is changed as B complement. Here complement of union. This means the elements not in A or B are the same as the elements not in A and not in B. Complement of intersection. This means the elements not in A and B are the same as the elements not in A or not in B. These laws helps simplify complex set of expressions, turning problems involving complements of union into intersections of complements and vice versa. These are the important law in the set theory. It is useful for simplifying the complex problems in the easier form. Here the final take. Here summary. Summary about the set theory is explained as set theory is a fundamental branch of mathematics, providing a rigorous way to define and manipulate collection of objects. Mastering its core concepts empowers analytical thinking across various disciplines. Here the foundational concepts in the set theories are: sets are foundational in mathematics, representing collection of distinct objects, and essential operations we have discussed previous slides, like understanding types of sets and operations like union, intersection, difference, complements is key to problem solving. Here the broad applications about the set theories are: mastery of these concepts opens doors to advanced math, computer science, and logical reasoning in diverse fields. Here the powerful laws of sets like De Morgan's mirror algebraic properties, enabling powerful reasoning and simplification. Explore further with practice problems and Venn diagrams exercises to solidify your understanding. Here about the brief explanation of set theory and operations laws included in this set theory. Thank you everyone.